Hi everyone, are you able to hear me and see the screen clearly? Yes, Pavan? All right, so all right, great. So welcome to the session on the Spark introduction to big data. All right, so all right, great. So I'm coming through fine and great. So welcome to a session on big data with Spark. It's an introduction course. In the first half, we will go over the introduction of Spark. We will also discuss what's better in Spark than the Hadoop. And we also will talk about the Spark architecture in the second half. There's going to be 10 minutes break. There's going to be a 10 minutes break. And then in the second half, we'll talk about Spark architecture. The session is being recorded, and the recording along with the presentation will be shared with all of you. So you don't have to worry about, but feel free to take the screenshot if you feel like. And yeah, so and presentation will be shared with you. Okay. Everyone except the instructor, that's me. Everyone except me is muted. Please ask questions by typing in Q&A window. All right. Please ask the questions by typing in the Q&A window, and I will read out the questions before answering. Please keep your messages short while asking the questions, but do not use too much of a chat language because it will be difficult for me to decipher. I'm not very good at it. All right, so this is the first session of the Spark. This session is open for all, and it suffices as the introduction to Spark and the big data technologies. All right, and so I'm Sandeep Giri. I did my graduation from IIT Roorkee. Then I worked largely on the large scale computing. I started my career in DE Shaw in 2002. We had a humongous cluster at that point of time, though we did not have the Hadoop at that point of time, but we did have our own custom software to handle humongous data. Then I worked with InMobi and Amazon. At InMobi, we processed 200 terabyte data and used Cassandra and Hadoop. At Amazon, we had our own streaming engine, and I was handling the detail page. So I have been mostly on the large scale computing, and I am software engineer at heart, and I enjoy explaining technologies. All right. So and I founded CloudxLab in order to make the learning of these technologies easy. So I'm sure I'll be able to do my bit by giving the today's session. All right. So please feel free to ask questions. By the way of asking questions is the only way to learn. Okay. The only way to learn is by the way of asking questions. So feel free to ask questions as much as possible. All right. Along with me, I have my team in the session. All right, let me just yeah. I have Abhinav and Aditya. All right, they will also be answering to your questions. Great. All right, so feel free to ask questions, and because we believe that that's the way of learning, that's the way forward to learn anything. Great, great. So about CloudxLab and the way we have our courses is, the way we have our courses are, we have live training. Along with live training, the self-paced course has videos, quizzes, hands-on, and projects and case studies. Every course has all of these along with the live trainings. Okay? And all of these, whether quiz, videos, hands-on projects, and case studies, all of these have been created to cater to real life use cases. All right. And the one unique proposition that CloudxLab brings to the table in case of big data is that our lab that's being used by many other instructors or many other have been inspired by the same lab. And along with the lab, what we have done is we have created automated assessment. Okay. So you get a problem statement in case of automated assessments. You get a problem statement, then you go and log in into the system and perform the problem statement. Only then the assessment returns successful. Okay, so this is the way it is. So once you actually log in, this is the problem statement here. And once you actually log in, then you click on this, then it will check whether you have done it or not, whether you have logged in successfully or not, and only then it will return successful. Okay, so this way you do not need an instructor or anybody. In case of exercises, the system automatically keeps helping you and helping you validate whether you are doing right or wrong, because it's not possible for the instructor to give you that instant feedback on how well you are doing. So that's why we have built a system which help you learn by the way of continuous feedback. You actually have to log in and do the commands, generate the data, only then it gives you successful. It only then it'll give you the grade. So we have built the entire system so that people can learn. We do not want to kind of assess people here. We want to help people learn. And and for that, the best way is to kind of make it gamified such that as you do things, you get the grades, you get the coins. And similarly, we have designed the system. All right. And how we are able to design it? Because we have a lab which is hosted cluster of computers, and where you all log in, and there you perform the acts, the perform whatever the problem statement is, and only then the system checks and is able to give you the go ahead. Okay, so since we had the lab already where people could log in and learn, all the tools were installed on the lab so that you don't have to install, and the same lab was accessible to all the people. Therefore, we were able to create automated assessment for big data and everybody. And that's why this is kind of a simulator for most of the certifications as well. Okay, so that's the idea behind the lab. And so we have those who have already signed up, you will be able to see this under my courses, and inside the course you will get the individual topics, or you can say them skills, and then you can go ahead. All right. So basically the core idea behind behind the course is that we all get the instant feedback from the system so that our learning can be robust. Okay, and the aim with CloudxLab is that we are trying to help people learn to solve problems, because that's something which is hard, and that's something which needs to be done. So so the aim with CloudxLab is, by the way of gamified learning, We are helping people solve big data problems or technology problems, you can say. All right. So let's start with our Spark introduction. Okay. So that was about me. Please feel free to write your introduction in the chat window so that we would be able to see it, and also we'll be able to understand the audience we have. All right. So please feel free to introduce yourself in the chat window. Yes, Pavan, you have raised your hand. You have a question for me. Hi, Vinayak. Thank you for joining in. Hi, Vilas. Great. Hello, Venkat. Great to have all of you in the session. Hi, Vinod. Hi, Kiran. Wonderful. Wonderful. So we are the most active community in Bangalore, and we help people learn the big data and the technology. Wonderful to have all of you. Hi, Databytes. It'll be great that if you introduce with a personal name. All right. Great, Anand. Uh, I'm very happy that you are here. So, all right. Great. So one more thing, in case you are stuck with a big data problem in your organization, please feel free to reach out. We would be able to help you. All right. This is not something we would charge you for, but we would be able to help you with respect to solving it with a quick consulting. All right. We already help our students with respect to their architecture related problem, or if they need a little bit of guidance. Most of our students are able to successfully are able to solve the problems. All right. Great. Wonderful to have all of you in the session, and would love to go into more details in Spark. Great. All right. So you have not missed much yet. I've introduced myself. I've introduced the CloudxLab, and I've explained that CloudxLab aims to build the automated learning platform, a gamified learning platform where there's no difference between the game you play and learning, right? So, so we are not like Coursera because we have the entire lab set up for our course, and most of our system is automated evaluation. So people get the lab, they log into our lab, then they get a challenge. They have to solve that challenge in the lab. Lab is basically a hosted system, and when they solve the challenge in the lab, they get the go ahead. Success or failure is dependent on how well they have done it. Okay. All right. Wonderful to have all of you in the session. Let's start with the course. All right. I have a great set of audience today. We have 71 people in the class, and I'm sure most of you are from great background. All right. Great. Yes, let's start the main session. Thank you, Samir. Great. So what exactly is Spark? So today's agenda is the introduction to Spark. Okay. This is going to be introductory level session. And we do assume that you have done a basic understanding of Hadoop. All right. Let's start with the session. Wonderful set of questions. Now, so Apache Spark is basically a fast and general engine for large scale data processing. Okay. Now, what does that sentence mean to you? What does that sentence mean to you? It means that it is only for processing. Okay. It's a processing engine which is fast and general, meaning it does not let you process only using, say, SQL or only using, say, a particular query language. It lets you do the processing in all kinds of ways that we'll learn very soon. And large scale means that you should be able to run it on many computers for data processing, as well as you should be able to run it on many cores in your machine. All right. So that's what this Spark is. It's essentially a really fast MapReduce. It's around, as per their claim, it's around 100 times faster than Hadoop. Hadoop's MapReduce, not the entire Hadoop. Hadoop has a component called MapReduce that provides the processing on top of the file system, right? And Spark is a competitor for the Hadoop MapReduce, and it's around 100 times faster if you run Spark in the memory. It's around 10 times faster if you're using the disk, and it builds on the similar paradigms as MapReduce. In MapReduce, we generally had to write mapper and reducer, and mapper used to run near the data, then the data will get sorted, and then the reducers will run. In the similar way, Spark also builds on the similar paradigm. All right. It is very well integrated with Hadoop. It is very well integrated with Hadoop, meaning that it runs on top of the Hadoop distributed file system. It basically can access the Hadoop distributed file system. It runs on Yarn, which is Hadoop's way of executing things in the network. So there is a component of Hadoop called yet another resource negotiator, which essentially let you write program which could be run in network, right? So Yarn is a very generic framework, and to write a program for Yarn requires a lot of work. Therefore, you either write your program for MapReduce, which internally calls Yarn, or you write your program for Spark, which internally calls Yarn. All right. So it integrates very well with Hadoop's Yarn and Hadoop's file system. So most of the components which Hadoop MapReduce can interact with, Spark can also interact with. For example, the way Hive can interact with MapReduce, Spark can also access the same meta store as Hive. Okay, do not bother if you don't know these terms. I'm just introducing because there are quite a few people in this session who are aware about Hadoop. All right, so do not panic, do not worry. Things will get clear. Do not worry if you don't know the Hadoop much. The only thing here to understand is Spark Core is a general and a fast and general engine for large-scale data processing. Okay. Now, question to all of you is Spark a data store? Is Spark like a database? Yes or no? No, right? Good, good. So Spark is not a data store. So from this definition, at least that part we can understand clearly. Okay. It's not a data store. It does not provide a way of saving data, uploading data, or something like that. It does provide you a way of caching the data, intermittent data, which is generated as part of the processing, but it does not provide a storage as such. All right. Okay. Now, the other thing that we need to understand is that Spark Let me just take a look at. All right, yeah, you are on the right track. Feel free to ask questions, all of you. Feel free to ask questions using Q&A window. That makes it easier for me to answer. All right, great. Now let's understand the Spark's architecture. Okay, so far what we learned is Spark can run on top of Hadoop, and with the Spark you can launch your own program. You can launch your own program which will be run in a distributed fashion, and and it provides you a similar paradigm like MapReduce of Hadoop. Okay, so in very simple words, if you want to do a large scale processing, meaning let us say that you have humongous data, petabytes of data, and petabytes of say Apache server logs, and you want to filter certain lines, right? In those cases, you can use Spark. Or let us say you have CSV files of an older data from your warehouse, and it's the data from the warehouse is in hundreds of terabytes of data. And what you want to do is you want to, let's say, find out find out from this data that how many of these records belong to a particular city or a country, right? In that case, you can use Spark or Hadoop MapReduce or Hive. Okay, so this is where Spark comes into play, because Spark is fastest amongst most of the general processing engine. All right. So when you have the processing need could be something like what database queries does. When you call a query, select star from this table, it's essentially a kind of a processing. When you say group by, where clause, and all that on a database, it's a processing, right? Similarly, let's say you want to run a machine learning program on your data. That's also a processing, and that can be done with MLlib, which is a part of Spark. We'll cover that part today. All right. So Spark's architecture, as per Spark architecture, Spark can run on top of Hadoop. If let's say your organization has Hadoop already, and you want to use Spark, you can right away do that. You do not need to install Spark explicitly, right? A question is this something similar to Pig Latin? In case of Pig Latin, the okay, those who do not know, let me select the question. Okay, a question is a very good question and at very right time. So let me answer this question. Question is this something similar to Pig Latin? Now, for most of you, what is Pig Latin? Pig Latin is basically a query language like SQL, but very simplified, where you define step by step. Okay, so the paradigm that Spark provides is very similar to Pig Latin. It is very similar in execution, just that Spark has not created a separate language like Pig Latin. In case of Pig Latin is the language and Pig is the execution engine. So Pig takes Pig Latin and converts that into MapReduce and does your job, right? So when you write Pig Latin, it's kind of a newer language and it's restrictive. In case of Spark, you can use any language. You can use Java, you can use Python, you can use Scala, you can use SQL, and so on. That's the difference, and that's the similarity. Similarity is the evaluation engine in case of Spark is Spark itself, while in case of Pig Latin, the evaluation is done by MapReduce. Execution is done by MapReduce, while both Pig Latin and Spark Core follow the lazy execution method. Okay, we'll talk about it after a while. All right. So a question from Ganiti is, why is Spark faster than MapReduce? We'll cover that part very quickly. after this one. So I'll keep your question open. All right. So Vijay's point is that there's a background noise. Is it better now, Vijay? All right. Okay. Okay. So is it better now, Vijay? Are you able to hear this clearly? Okay. Great. Great. All right. T2 says that there is no background noise now. Okay. All right. Yeah, actually I'm moving. That's why I'm a little walking. That's why there might be a little bit of. Okay. All right. Now let me answer questions. There is one more question from Kunar, which I'll answer in a minute. And Raghu's question is great. Question from Raghu is what are the other tools available for data processing? A good question. So there are quite a few tools that are available for data processing. There is Storm, there's MapReduce, there is Hive, there is Big Latin. There are other tools which are some of them are not distributed, but in case of distributed, I think Spark, MapReduce, and Storm are the examples. Or there is something called Splunk. There are some more distributed processing tools. All right. Though all of the programming languages are designed for data processing, right? Whether it's Perl, whether it's Python, all of these programming languages traditionally were designed for data processing. And, and Spark makes it possible to run those programs in a network. All right. So general processing engines are many. The distributed ones are Spark, MapReduce, Storm, Kafka, and few more, SA, MongoDB, and Cassandra, and so on. All right, good question, Raghu. There are a few more tools. A few more questions I would like to answer. Okay, a question is, so MapReduce is a concept or processing tool? Good point. So it's both. Okay, it's both. MapReduce is a concept as well as a tool. So if you look at most of the procedural programming languages, say Python or Perl, they all have a function called map. They all have a function called reduce. Okay, that's where the idea came into play. Now, in case of Hadoop MapReduce, it's a tool which takes two pieces of programs from you. One is mapper, one is reducer, and it runs the Hadoop MapReduce take those two pieces of code and then runs it in the cluster in a distributed way in certain fashion so that you can achieve what you have planned to do. Okay, so Hadoop MapReduce provides a way to process data, and Hadoop MapReduce is a proper platform which actually runs your program in the network, similar to Spark. A question from Rudra is, what are the real-time applications examples where Spark is used? Honestly, I had not planned for that part. I was assuming that big data introduction generally covers it. So wherever you need to process data in the batch-wise on a streaming way, you use Spark. Specifically, where your data is big. When your data grows bigger than what can be handled, when your data becomes bigger than what can be handled by a single computer, then you generally require distributed platforms. Okay? When when you are not able to store so much of data on a single computer, you go for Hadoop kind of system or some other similar system where you store data on many computers. And in case you are doing some processing and you realize that the theoretical limit of that computer has reached and you are not satisfied with the speed or the time it takes, then you go for a distributed platform, distributed framework for processing such as Spark or Hadoop, which can utilize many computers in order to solve your problem? Very good questions. Okay. All right. Is Pig similar to Spark? Pig was an older way. It was restricted to Pig Latin. So you needed to create the program using Pig Latin. It was hard and not many use cases were solvable with Pig. Okay. Is Spark based on MapReduce? No. Spark is a competitor for MapReduce, but it borrows the ideas from Pig. It borrows the ideas from MapReduce, and and therefore it's kind of independent platform. A question from Summer: is it possible to use Ruby with Spark? Ruby, I'm not sure. Maybe there is a JRuby version of it which you can use, but theoretically it should be possible. Theoretically, it should be possible because you can make the call to the Spark library from any kind of languages. Question is, does the core of Hadoop Spark is concurrency? No, the core of Hadoop Spark is distributed computing. Concurrency is just one feature. Concurrency, probably you're confusing concurrency with the distributed computing. Distributed computing means that you utilize many computers to solve your problem. Okay? That's what is distributed computing. While concurrency is that you're doing concurrent tasks on the same machine without intervening with other one. All right, great. So I'll answer your 4 questions very soon. There are 4 questions left. And yes, T2 also, I'll answer your questions very soon, and probably your questions will get answered very quickly. Okay. Another question is, Hadoop and Spark are 2 different things. Yes. All right. Hadoop and Spark are 2 different things. What language is Hadoop based on? Okay. All right. A good question again. So Hadoop and Spark are 2 different things. Yes. These are 2 different softwares. Hadoop is a different software than Spark. And you can say bundle of softwares actually. So Hadoop was the previous one. Hadoop contained many other software. One for storing files, other for storing records like a database, and other for doing computation in the using any programming language. So like MapReduce, you could call from Python, you could call from other languages, and and while there were another tool in Hadoop called Hive, which lets you write SQL query and do the processing. Okay, so Hadoop was created using Java, but you could write program in anything. When I was using Hadoop for the first time, we wrote the MapReduce logic using Python, and later we changed it to Java. So it was completely perfectly fine. And some of the part we actually wrote in shell script. Okay, so most of the work can be done in any programming language. All right, that war of programming languages is not a big deal, and therefore most of the programming languages are supported pretty well. All right, now question is, I hope I have answered your question. All right, great. Yes, Samar, that's right. The the Spark can run on top of Hadoop, though it's a independent software. It can run without Hadoop as well. Okay, so Spark is a competitor of Hadoop MapReduce, and it can run on top of Hadoop as well as other platforms. Great set of questions, and I would love to answer these questions very well. Great. So Spark can run on top of Yarn, which is a part of Hadoop. Spark can run on EC2. Spark can run on standalone as well, or it could run on Mesos. If your organization already has Hadoop, then also Hadoop can run, Spark can run. And if your organization is using EC2, Amazon's Elastic Computing Cloud, then also you can use Spark there near your data. If your organization is using Mesos, Mesos is another resource manager. What is resource manager? In order to manage the resources of your cluster, you generally use this layer called uh, resource manager, and Mesos is that. Mesos, Yarn are those resource managers. All right. In case your organization has none of these, Spark comes with its own standalone resource manager, which you can install in the network, and then you can run Spark on top of it. Okay, so Spark comes with a standalone resource manager with itself, and that component can run on the cluster, and then you can distribute the work in your cluster. So that's the way. So Spark can run almost all kinds of cluster or resource managers. Okay, so if you go to your admin in the organization and say that, hey, I want to run a Spark core, and he says, no, we have only Hadoop. So you could say that Spark can run on top of Hadoop, and he doesn't need to install anything. Okay, keep that in mind. So you don't need to install anything extra in order to run Spark on top of Hadoop. Okay, even if it's not, even if Hadoop was not installed with Spark. Great. Now, Spark can talk to any data sources, right? The processing, when we say processing, processing makes sense only if there is data, right? You always do processing on top of some data, or you do processing in order to generate data, right? So you need data sources in order to process, correct? Mostly, right? And the beauty of Spark is that it can read from almost every data source, whether your data is in Hadoop distributed file system, HDFS, right? Hadoop distributed file system is what? It basically spreads your data in a network so that many computers' hard disk can be utilized for storing the data. That's Hadoop distributed file system. Then there is HBase, which runs on top of HDFS. There is Hive, and there's Tachyon, and then Cassandra. So you can see that, and many more actually. So Spark can read the data from multitude of data sources. It can read data from multitude of data sources. And the libraries, so you might think that for everything I'll have to write code. No. Spark provides these wonderful set of libraries. One is data frame, the first one, the data frame. That's so powerful library that you don't need to write your logic anymore. You can write the things in terms of SQL queries. We will focus a lot on data frame in this course because data frame is in very much use. So you don't really need to keep on writing the loops. You can simply use the data frame. Okay, with SQL, you can say that you can convert a raw data into a tabular structure and then execute the complex queries in the form of SQL. So if you are not confident with a programming language like Scala or Python or something, you can still use data frame very easily by just using the SQL kind of syntax. All right. Now, the second library from Spark is a wonderful library called streaming. So let me ask Vinod's question parallel. Do we use Spark for real-time processing? Almost yes. So if your processing is, if you are okay with processing the data with a second of delay, 1 second of delay, then you can use Spark streaming. If you are not okay with that, you can use for other engines such as Storm. Now, so what is streaming? A question is, what is streaming? Spark streaming. Spark streaming is, let's say data is coming continuously. Let's say you have, say you are reading Twitter feed in real time and you are generating the sentiment analysis, right? So we can use streaming at that point of time. Or let me give you another example that you are running this. So this is what we're talking about. Okay. So, oh, it doesn't work well. All right. So coming back to the point, what I was saying, that streaming means that if there is a data flow continuously, you can process the data by breaking it into the batches. And then using the processing of that batch can be done using many computers. So streaming means there's a continuous data and you would like to process in real time. Then another example that I was trying to give you is, let us say that you are running a e-commerce company like say Dell. Dell is one of the division is e-commerce where they take orders from the website and deliver the laptops, right? So you would like to see in real time how many orders are placed, how many are being shipped, how many are being assembled, and what's going on. If you want to, if you need that kind of, if you need that kind of um, dashboard, you can use Spark Streaming to generate data which can be represented using the using the visualization tools. Okay, so one of my teammates can actually share with all of you a blog which we wrote about a use case of Spark called streaming, which is being used as the white paper by many people in order to implement the real-time streaming of using Spark. Okay, so one of my teammates can share the blog post. We have a blog at CloudxLab. You can also take a look at it. All right. So yes. So I was trying to explain the what is streaming. Streaming is processing the data in almost real time, and the data is continuous. What does it mean by continuous or unbounded? It is also called unbounded data processing. It means that data is coming continuously. Normally, when we run programs, we run it, right? When we run a program, it does the processing, finishes, and then goes then shuts down, right? That's what it happens. When you run a program, it does the job, then it shuts down. But streaming is, it is processing data as in when the data is coming, meaning the program does not stop as such. If there is data, it'll process. If there's no data, it'll wait for the data to come in. That's streaming or unbounded data processing. All right. So yes, Spark provides a library that helps you do the streaming. Okay. All right. I'll answer your questions very quickly. A question from Santos is it real-time analysis? Yes. It's, yeah, almost real time. So Spark streaming gives you the real time of around 1 second window. All right. A question is there a framework similar to Spark other than Hadoop? There is not many, though there is another one from Google called TensorFlow. They are trying to be, but it's still not ready for the kind of use case industry has. That TensorFlow is generally good for only the deep learning. Okay. All right. I hope. Great. Now coming back to the Great. Now, coming back to the point that streaming is one of the libraries. Next library, which is very powerful and is useful, is MLlib. Okay. MLlib is MLlib is a machine learning library, right? What is machine learning? Training computers to learn by itself. That's what is machine learning. be so that the computer can learn by itself from the data, and you don't have to explicitly write the algorithm. That's machine learning. That's the machine learning as brief as it can be. Now, there are many machine learning algorithms which are complex and take a lot of time, such as, let's say, recommendation engine, which generates the recommendation automatically. Those kind of most of the algorithms in machine learning requires a lot of data, and a lot of data takes a lot of time in processing. And hence, it's imperative that machine learning needs to be distributed as much as it can. What does it mean by distributed? Running a logic or getting a work done by using multiple computers. Okay, so MLlib, the machine learning library of Spark, provides you almost every machine learning algorithm such that it can be run using multiple machines at the same time. If your machine learning program is taking a lot of time on a single machine, you can use MLlib. Earlier, in case of Hadoop, we had Mahout, but Mahout was extremely limited, and therefore, Spark, the MLlib was created, which provides you almost every algorithm of machine learning along with the data structures. The next part of Spark is GraphX. GraphX is for graph processing. Okay, and as a user, let me answer. So as a user, you can use SQL, you can use SparkR, you can use Java, you can use Python, and you can use Scala to talk to Spark, whether you're trying to use data frames, Spark streaming, or MLlib or core of Spark. Either of this can be accessed using any of these languages. Okay, even GraphX is now available in graph frames. Okay, a library called graph frames makes it possible to be used via Python. Okay, yes, Sanjay, the session is getting recorded. All right. A question that Ganiti has also asked. Question is, why Apache Spark? Or why is Apache Spark faster than MapReduce? All right, let's understand. It's a long question, and let me answer that. Okay, what we did in case of Hadoop MapReduce, you wrote the program, right? That's one in using the headphone this side. Okay, that's you. You wrote map and reduce, right? And gave to Hadoop's MapReduce. Hadoop's MapReduce read the data from HDFS, ran your MapReduce, and saved the output to HDFS. This is as simple as I can make it. I have dumbed it down, make it extremely simple so that we can understand it clearly. So you wrote the Hadoop MapReduce program, you sent the code, not the data. You sent the code to MapReduce framework. And MapReduce framework ran your logic nearer to the data in HDFS, but it did read the data from HDFS. And then once it was done, once the Hadoop MapReduce job was done, it would save the results to HDFS. Okay, so so if you had multiple phases of MapReduces, it looked like this. If you had multiple jobs, let's say you're counting words, but you want to find out top 20 words, top 20 most frequent words, right? If you have to find that out, you will have to use two MapReduce phases. In case, so all of you, those who are coming from MapReduce background or Hadoop background, you must have seen that we did that word count program. In the word count program, we did the frequency counting, find the frequency of each word in the text, right? That's the first program that we learned. So if you think about that program, it required sorting of the words and we did the counting, correct? But let's say you want one more thing. What you want is you want to find out what are the top 20 most frequent words. That means first you have to compute the word count, then you have to order the data by the counts, correct? And then get the results. And so you can see that there are two ordering phase or two sorting involved, first by the words, second by the counts. And therefore, there were two jobs of MapReduce required, correct? So the point here I'm trying to say is, in case your program, in case your query involves multiple jobs, what would happen is there will be multiple interactions with HDFS, right? So your MapReduce first job would read the data from HDFS, write it to HDFS, then second one, read it back, and then write it back. So there's a huge delay in case of Hadoop MapReduce, because instead of skipping it here directly and giving the data to second phase, it's basically writing it back to HDFS. That's one of the reasons why Hadoop MapReduce was slower. So Hadoop MapReduce was basically a batch-wise design, meaning every MapReduce cycle reads from and writes to HDFS. There was a heavy latency involved because it took some time to read the data from HDFS, and then it also took some time to launch the mapper and reducer every time. And also converting the logic, even for seasoned architects and programmers, converting the logic to MapReduce was difficult, and in-memory computing wasn't really possible. Those are the reasons, and those were the shortcomings of MapReduce. Now, imagine that MapReduce, instead of writing to HDFS, is writing to RAM. And RAM is around 80 times faster than the hard disk. RAM is around 80 times faster than the hard disk, and HDFS is far more slower than a hard disk, by the way. Therefore, this model made Spark really fast. Hadoop map the MapReduce phase. If MapReduce phase wrote to RAM instead of HDFS, it could have been extremely fast. Okay, here are some of the numbers. It shows that the disk is 20 times slower than the memory. Sorry, 80 times slower than the memory and 20 times slower than the solid state drive. Okay, so those were the reasons why MapReduce was slow and Spark is fast, because Spark reads and writes and utilizes memory whenever required. This does not mean that if you don't have very huge memory in your systems, it Spark won't run. That's not true. Spark can run in a normal memory machines as well. Okay, it will utilize the memory very wisely instead of either leaving it completely empty or consuming the entire memory. Spark uses the memory wisely in order to speed up the computation. All right, very good set of questions. Okay, I think that thank you Fakhruddin for that question. So the question is, so the Spark demands to have a lot of RAM available on all data nodes. The answer is no. If you have more RAM, it'll work faster, definitely. But if you have less RAM, average RAM, it's still okay with that. All right. We'll learn that how to manage the RAM in case of Spark during the course. All right. Wonderful question. Okay. There are a few questions that I would like to answer. And yes. Okay. All right. So great. Now a question from Rahul is, does Spark provide any compression or encryption library? So Spark does not provide out of the box, but it utilizes the compression libraries provided by various languages and various third parties. Okay, so it does have great support for almost every kind of compressions. All right. So though they have, most of these libraries can be enabled and disabled with Spark. Okay, and you will learn that. So there are, when you are reading data or writing data, there are many things to it. One, what kind of format is your data in? Second, that format also dictates how efficient would it be to process it, right? So whether your data is in CSV format, JSON format, or is it in Hadoop RC file format or something else, right? Similarly, there's a compression. Compression also matters in distributed computing. Why? Because if your file is divided on many machines, and if the compression demands that you bring all the chunks of a big file to a single machine and only then you can uncompress it, then the whole purpose of storage is lost. Therefore, there are many compressions and Spark is okay with most of them. A question from Rudra is MapReduce only useful when the job can be divided and merged? When the job can be divided and merged. Question is, it, so, so it's not only MapReduce, but most of the framework are useful when the job can be divided and merged. Okay? Job can be divided and merged. That, imagine that your next, whenever you are generating something, whenever you're doing something, it requires the previous computation. Imagine the Fibonacci series. How many of you know Fibonacci series? Please raise your hand. Fibonacci, I think they call it. Okay, great, great. A lot of you know what is Fibonacci series. In Fibonacci series, what we do is the next number is function of the previous two numbers, right? That means such programs you can never distribute, because for the computation of the next one, previous computations are required and so on. Therefore, those kind of programs can never be divided and merged, right? And second kind of things that Hadoop or Spark is not great with is when your every computation requires you to talk to a central database. Okay, imagine that for there are a huge number of records but for all record processing, you need to talk to a database, right? So your bottleneck would be not the computing platform, but your bottleneck will be that database from which every machine or every record needs to talk to. All right, that's why if your computation involves a sequential processing like Fibonacci, or your computation involves your computation of every record involves a central database or central system, then your computation will be as fast as the central system's response time. Okay, in those cases, most of this distributed computing is not useful. Great. Again, a question from Tiru. Spark on HDFS uses RAM. Can we run Spark on commodity hardware? How do we calculate RAM requirements? Okay, good question. So basically, Spark does utilize RAM, but it utilizes RAM provided by the resource manager. Okay, if resource manager provides only 2 GB RAM, it will only consume 60% of 2 GB RAM for your data processing. Rest of 40% will be for the intermediate buffers. Okay, we'll talk about in detail about the RAM requirements and how does the RAM computation work in case of Spark during the course. All right, so question is, Spark on HDFS uses RAM, yes, but only the one which you allocate it to. Second, can we run Spark on commodity hardware? Yes, because you can run Spark happily even if you are dedicated only say 512 MB RAM on every machine. Okay, all right. A question from Rahul is any disadvantage of using Spark over Hadoop? I don't think there is any. Okay. The only thing that could happen is if people are using Spark long running processes, it could take, people could end up consuming a lot of resources for a longer duration. Okay. Because Spark allows you to have long running sessions as compared to the MapReduce. Okay. Um, oh, sorry. I think I understood your question wrong, Rahul. Question is any disadvantages of using Spark over Hadoop? So, okay, there are two ways of interpreting your question. One way was previous one that comparing Spark against MapReduce, the disadvantage of Spark against MapReduce. The second way is there any disadvantage of running Spark on top of Hadoop's yarn? Okay, if that's your question, my answer is that not many. Okay, Yarn is also quite mature framework, and therefore it's completely okay to run Spark on top of Yarn without having to worry about things. All right. Okay. So, all right. Prashant's question is, can you repeat the compression part? Okay. Compression part is yes. Spark supports all kind of compressions. All right. Spark supports all kind of compressions, and I talked about that why compression is important. Compression is important because compression is important in case of distributed computing. There is a very important idea here. So when we store data, a huge file in case of Hadoop, right? So Hadoop is still used for storage. Spark doesn't have a storage. Okay. So Spark would read the data from Hadoop. Imagine that you created a file in zip compression in HDFS, right? And in zip compression, what happens is the file is compressed in a way that to decompress the file, you require all of the parts. Individual parts cannot be decompressed. Those who are from little older time like mine can recollect that we used to have these multiple floppies and we used to insert all those floppies in order to get uncompressed data from zip. Okay, so compression in case of distributed is very important. Therefore, after a lot of research, people have figured out there are good compressions like Algedo, GZAD, and so on. So Spark supports all of the compressions because it's not Spark's job. Spark just lets you use the libraries as such. Okay. Question from Asad. So everyone should be switching to Spark gradually? Yes, theoretically, yes. Okay. A question from Prithvi is, data frame is a data structure or a framework? Data frames is both. Okay. So on one hand, data frame is just a structure. Why? So I'll say this way that data frames is a library, okay? Library which provides a data structure and a function, a way to run the query and convert it into Spark core. Okay, so data frames layer, or we also call data frames in Spark SQL is kind of used interchangeably. Data frames is part of a library called Spark SQL. Data frame is basically a data structure on which you can run SQL query or you can run R kind of a syntax for processing. Therefore, the data frames library or Spark SQL which is used interchangeably. There are two parts. One is data structure, and other is ability to execute the SQL or R query on it. Good question. All right, great set of question. A question is from T2 is, do you have any experience with Google Dataproc? Not yet, not yet. Okay. All right. So I'll answer your question, Dinesh, in a while. All right. A question from George is, so is Spark going to replace Hadoop? Mostly it'll replace the Hadoop MapReduce jobs. Okay. All right. Let me pause my screen for a second. If you have any questions, please feel free to ask. Yes, the session is on. I'm waiting for your questions. All right. Okay. So yes, the session is on and good. Okay. A question from Dinesh is that can you please tell the difference between oddity versus data frame versus dataset? Okay. A good question. And let me explain. All right. So let me see if I can. Okay. All right. So let me see if I can explain to you. I have a good slide over there with that idea. Or let me just try the simple way of answering. Okay. A question is, When we talk about Spark, when we talk about Spark, we generally load the data and then we run the logic on that data. And when we say load, it doesn't really mean that we load it into memory. We generally just define that we are going to load this data from this file. Okay, that's what is called an oddity. Oddity is a construct from oddity is a construct from Spark around which the whole Spark revolves. Okay, oddity around oddity the whole Spark revolves, and the idea in case of oddity is that we should be able to divide our work into many records, and those records are going to be loaded using many computers simultaneously. Okay, so RDD is the core concept. RDD means resilient distributed dataset. Okay, that's the core idea behind the RDD. Okay, or maybe I can jump a little ahead if you want. I can just pick up the, don't worry, and it'll be completely okay. All right, I'll just take you to this one. So the question that Dinesh has asked is a little advanced, and therefore I'm just deviating a little bit more. Don't worry, and you'll be able to understand it clearly. Okay. So so far what we have discussed is that Hadoop's MapReduce was little slower than Spark, and therefore people are using Hadoop's. Therefore people are using Spark. Spark provides you various libraries for creating data frames and other kind of processing. Okay. Also, Spark can run on various kinds of resource managers and clusters, as well as Spark can read the data from all kinds of systems. Okay. Now, one the basic idea in case of Spark is RDD. RDD means resilient distributed dataset. Okay. When I say dataset, it's collection of data elements. Dataset is set of records. Okay. In all kinds of systems that you have so far used, whether it's an array, tables, data frames in R, or collections in MongoDB, everywhere there is a concept of data set. Okay, wherever we have the data processing, generally we have the notation of a data set. Data set is a collection of records. Okay, and in case of RDD, each record can be anything. It doesn't have to be an array of values. Okay, so you can always think of an RDD like a huge array, like a huge array. And it is not a storage, it's just a data representation. Okay, it's just a data representation. Okay, so and it's distributed, meaning RDD has got partitions, and each partition is generally loaded on different machine. Okay, and it's resilient in case one of the machine dies on which RDD is loaded, it is recalculated. That's what is resilient distributed dataset. Okay. All right. Next is, okay, so this is how you can think about RDD. RDD is some elements here, some elements here, some elements here on machine 3, and some elements here on machine 4. This is what this one shows. If you have, say, 4 machines and you have a huge array of numbers of 15, and you have created 4 partitions, this is how your RDD looks like. RDD is having 15 elements from here to here. Okay, this is RDD. It's not really loaded into the memory. When you run it, only then it will be loaded in the memory, and that's called lazy evaluation. We'll talk about lazy evaluation. Now, a question is, what is the difference between the data frame and oddity? Let me just pick out another thing which that'll make answer easy, because there's no straight answer for this question. It's a tough question. Okay. All right. All right. So you can think of RDD like this, whereby every record, I mean, I've done the similar thing. What it was horizontal, I've just drawn it vertical. Okay. So RDD is something like this. Here, every record is a string in which one space Sandeep is stored. Okay. This is RDD, which is having lines of lines as records. Okay. How many records does this RDD have? 1, 2, 3, 4, 5. Okay. And this RDD has what? It has a line of text. Okay. This is called RDD. And converting this into columns and rows is data frame. Data frame has how many records? 1, 2, 3, 4, 5, right? And each record has fields. Each record has columns, and every column has got a name. This is called data frame. Okay, this is called data frame. And basically, mm, RDD is first converted into data set, and then on data frame, essentially under the hood is data set plus something that provides SQL and R kind of a syntax. So data frame internally is a data set. This is basically the data set structure. It has a column and the name. Data set plus SQL and R kind of query. You can run this kind of a query on a data frame. Okay, on this data frame, you can run a query like this. Okay, so RDD versus data frame is data frame is structured data, while RDD is unstructured data. While data frame and data set both are same thing, just that data frame equals to data set plus SQL and R query processors. Okay, great set of questions, and yes, I hope that was useful and I was able to explain. A question is, can I say that a flat file data is RDD? You can say it in a way. We can create RDD out of a flat file. We can create RDD out of anything. You could, let's say you have an array of objects in the memory. You can create an RDD out of it. Okay, so yes, RDD can be created out of the flat file. Okay, a question is, don't worry if I'm deviating, because we'll cover all of these topics in more details. Okay, we'll cover all of these topics in more details during the course. All right, we'll cover how to convert the data from one form to another, or how to directly create a data frame from all kinds of formats. We will focus more on Spark SQL in this course. We will reduce the dose of other parts. Okay, so because data frames is something, data frame or Spark SQL is the same thing that I'm interchangeably using. So that's where we'll spend more time. Okay, a question is, question from Carlos is, with Mesos Spark not need HDFS? Good point, Carlos. So Mesos can work with many other file systems. Okay, Mesos can work with many other file systems, and Mesos does not provide a HDFS, a file system out of the box. So yes, A very good question. So question, let me reiterate for others. Question is, let's say we are running Spark on top of Mesos. Can it read the data from HDFS, or how will it how will it fulfill the storage need? Okay, so if you have both the clusters, let's say one is running Hadoop, then you can use HDFS. Otherwise, if you have some other file system, you can use those. Though there are some file systems that are provided on top of Mesos or with Mesos actually. Okay, so yes, I hope I have been able to answer your question. So needing an HDFS or not needing an HDFS is a business requirement from your side. Okay, if you mean that with Mesos Spark we need storage, we do, and generally there are some. Okay, all right. Carlos, did I answer your question? No? Okay. A question from Tito is, will you cover indexing later? Indexing in case of in case of Spark, it basically does not provide indexing out of the box, but there is something, the ideas called sorting, there are ideas called partitioning. Those ideas we'll be teaching in the course. Okay. A question from Krishnakant is, can we push this data frames directly into NoSQL DBs? Yes, we can. Okay, some of the DBs provide you a way to push these structures into the NoSQLs. Okay, some of the NoSQLs do provide. A question is, what is the difference between Flume and Spark Streaming? Good point. So those who are not acquainted with Flume, okay, let me reiterate, what does it mean? Flume essentially pushes data from all places. Okay, let me just draw it for you. Okay, it's an important question and I would love to answer it in detail. Okay, so imagine that you have many web server in your organization and all of these are generating logs. All of these are parallelly creating these data files that contain the history of what's happening on your servers. That's generally called logs. So all of these machines are continuously generating that. What you want is you want it to be pushed to a central file system such as Hadoop distributed file system, right? That's a very common need. And if you just want to just push it, as in just copy the data to HDFS, then Flume is the most flexible and most powerful tool. Okay, it'll just keep on pushing data from here to here. While Flume lets you push the data from all kinds of storages, all kinds of places, and all kinds of sources into HDFS using a complex hierarchy or using complex systems. Okay, Flume does not provide you a processing. Flume does not provide you the processing. Okay, what Flume provides you, this way of pushing data, and in case you want to process it, you will use Spark streaming. Spark streaming. So what is going to happen? On one hand, the data is coming from all the machines using Flume into an HDFS folder. And if you remember and recollect, in case of Flume, what was happening is it was pushing data continuously into a folder in HDFS, right? It was continuously creating new files in HDFS and pushing data from all of these machines, right? Now, with Spark streaming, you can process that folder. You can process that folder here. Okay. So whatever is the HDFS folder you are putting the files into, Spark streaming will take it and process it. Okay. So Spark streaming, what it will do is for some batch of files, It'll continuously keep on creating the RDDs and run your logic against RDDs or data frames. That's what it does. Okay, so I hope that I answered your question. So Flume provides you pushing the data while Spark Streaming provides you the computation. Okay. A question from George. RDD versus Hadoop file system. RDD is not a storage. RDD is just a representation of data. The way you have array data structure in case of things, or you have like pointer to data. Similarly, an RDD is essentially pointer to the data. RDD does not have, RDD is not a storage. While Hadoop file system is a very powerful storage where you can store petabyte of data using hundreds of computers or whatever storage you have. Okay, wonderful, wonderful. A question is, can we push the data that, yeah, this I have answered. Question from Carlos is, what's the speed? What's the speed? Okay, this is a question that I would love to answer and I would like to show to all of you. Okay, so the question is, Carlos, it will be great if you could ask using Q&A so that I could quickly answer. Okay, you have already asked. Thank you. All right. No, actually. Okay. All right. Let me just put it here. Question is, what's the difference in the performance in Scala versus Python? Okay. What's the difference in the performance of between Scala and Python? Okay. The answer is it depends. Okay, there are multiple answers to this question. I'll try, you know, I'll try to see if I can answer. It's a hard question to answer. Number one, that there is difference, but the difference is very small. Okay, the difference is very small. Why? Because in case of Spark, the main burden or main time is consumed in transporting data. In most of the big data problems, it's about the speed at which you can read data. And that's where the difference in programming languages is hardly few seconds. Okay, and that difference is very small. Second, the bigger difference, that difference, that minor difference, is generally due to a couple of things. Number one, the serialization formats plus the language itself. Okay, language itself. Now, the difference in case of computing between Python and Scala generally arises due to the serialization format, because the objects need to be serialized. In case Python objects are not getting serialized properly, they'll take more time. Okay, the language itself does not play too much of role. So the difference is very small, and the difference that arises is in the way we distribute our data, in the way we build our program such that the serialization is proper. Other than that, there is not much of a difference. Oh, all right. Okay, so there is not much of a difference. Very good questions. Very good questions. A question from Samir. During Spark streaming with HDFS, what happens to old data set already in HDFS? Very good question. So when you do Spark streaming from HDFS, what it does is it starts from what folder or files are already there. And as and when new files are getting created, new data, new RDDs are formed and processed. The older RDDs are not picked up. Okay, so generally the idea is that's why Flume generally creates new files instead of keep on appending to existing files, so that systems like Spark can pick up new files and do not pick up the older files which it has already picked up. Okay, so good question, Samir. All right. So while processing data using Spark Streaming, you have to ensure that you always create newer files instead of keep on updating the older files. A question from George is, to be successful big data analyst, which language should I learn? I think if you are new to computing, Python should be good enough. Okay. If you are joining this course, we will be teaching you Scala, and that should be good enough. Okay. All right. Great set of questions. And all right. Wonderful set of questions. I'm sure most of you are able to relate. Please feel free to ask questions if you have. Yes, Pawan and George, you have raised your hand. A question is, would I see examples of execution of some program, Scala with Spark like demo? Yes, I'll try. Okay, I'll try today. In second half, let's do some hands-on. Okay, the way I'm looking, I was actually planning for doing more theory part, but looking at the audience, I'm thinking of doing more hands-on. I hope that'll be okay with the class. All right. A question from Kunar is, how do I contribute to Spark? You can actually go to the apache.spark, spark.apache.org, and there's a guide for the contributors. Okay. And the idea, if you are looking to contribute to Spark, the general strategy is you start with fixing documentation. Then, if you are going good, you can pick up some of the test cases, and you can later on you can pick up once you are acquainted with the architecture, then you can pick up the the bugs to fix, and then if that get accepted, then you can contribute to the core. All right. A question from Rudra is Spark based on master-slave architecture? Kind of, yes. But it does not have servers running all the time, the master and slave. It uses the resource managers, master and slave, in order to get its work done. We will understand it in more details during our session. Okay. Okay, looks like most of you want more of hands-on, so I'll do the more hands-on today. Okay. A question from Meghna is, I had seen Spark documentation. I can see structured streaming. Does it deal with only structured data? Also, is it alternative to Spark streaming? Okay, good point. Good point. A question from Meghna is that there is something called structured streaming and there's something called normal streaming, right? So yes, Spark provides both kind of streaming now. It provides a streaming on data frame as well as on RDD. Okay, we will learn it during the session. All right. So right, because earlier, so you for everything you had to write programs and get it done. And earlier when we were talking about the Spark streaming, um, we had to always write the code. And I remember when we were working with one of the projects that we have shared the link with you, that real-time dashboard. So um, most of the things that could be done very well with SQL, we ended up writing code, right? And thanks to the structured data like data frame, we are able to write SQL, and the same thing has been used in structured streaming. So earlier, when there was no data frame, we always ended up writing code. Okay, but when data frame came into play, we don't need to write code. We can get things done using SQL or R kind of syntax. But and same is true for streaming. When earlier we had to write code for streaming, for processing data in real time in the batches, we had to all the time write code. But after structured streaming, we don't need to. Our SQL will be executed every batch that gets created per second basis, or whatever time window you define. Good question. Samar's question is, how big is the Spark community in India and what are the upcoming opportunities in it? Okay, so that question is hard to answer. And first one. Second one, I can try to answer. What are the upcoming opportunities in it? There are quite a few opportunities in Spark, as in a lot of algorithms are being translated into Spark, and most of the MapReduce systems that were built earlier are being translated in Spark, and also most of the data warehousing will be moved to Spark very soon. Okay. Could you please summarize all that has been covered so far till now? What will be covered in the second half? So what we have covered is one, what is Spark? Then we covered the Spark architecture, we give a brief overview of every component. Then we also talked about that why Hadoop MapReduce was slow because of the architecture. And then we talked about, then we talked basically about the architecture of the ma- na- we talked about questions actually after that. After this point, we talked about question and answers. Also, we talked about basics of oddity that we will cover again, so don't worry. Okay. The PPT would be shared with all attendees. Yes. Wonderful. Okay, great. So should we take a break for 10 minutes and be back by 9:45? Break for 10 minutes, back by 9:46 p.m. Okay, so I'll just display that in a notepad. Okay, All right, so I'm back. Should we start? Great, great. A question from Fakhruddin is that if the Flume is continuously creating new files in HDFS, how does Spark knows the Flume's file write is complete and is ready for processing? Wonderful question. Anybody? Okay, anybody has an answer? Let me. Okay, see. Great. Very good question. So question is, those who are using Flume in past, so and I also talked earlier that as and when you are using Flume, it creates files, write data to it, and then you can do the processing of this data continuously using Spark streaming. As in when new files are created, Spark will pick it and process it. But the question is, the Flume will take some time to write data to a file, correct? It will take some time. And in the meantime, what if Spark picks up the file? Okay, the answer is Flume creates files with a TMP suffix. Okay, and while processing data using Spark, you would not pick the files with a TMP suffix. Okay, while processing a folder, you generally say that this is a folder and this is the pattern of the file that we are going to pick up. Okay, and that's how it works. So once Flume finishes writing, then it basically renames .tmp to a normal file, and then Spark will pick it. Okay, so that's how it is. Good question. Good question. I hope that. All right. So we have already installed Spark in case of CloudxLab. What is CloudxLab? We have a cloud-based lab as well, and in which we install all the components that you need in order to learn data science, machine learning, or deep learning. Okay, so you do not have to install anything. Okay, you simply have to log in into Web Console and then get started with the commands. Okay. In case you want to download, you can simply download from Spark's website. And in case you have a cluster, although is you can run Spark happily on your desktop, and you on desktop as in you can just download the zip and unzip it and run the binaries stored in the bin folder. Okay, so if you are using PySpark, you will have to install Python on your machine. In case you are using Spark Scala, then you might have to install Scala on your machine. Okay. Okay. So in case you have a Hadoop cluster, what you have to do is find out the Hadoop version on your cluster. Find out the Hadoop version on your cluster using Hadoop version, and then go to Spark website in the downloads, select the release of your version and download Spark. And on the servers, since downloading, uploading is too much of a task, just copy the URL, whatever they give you to download, and use wget directly on the server, and you can get started. Okay, every download can be run very well in standalone, in basically local mode, not standalone, and you can basically use unzip command using tar, and that's it. Okay, the bin folder of your installation would contain the binaries. Okay, What are the commands provided by Spark? Okay. What are the commands provided by Spark? Spark shell, okay. Spark shell runs Spark's Scala interactive command line. Okay. In case you know Scala, you can use Spark shell. In case you are a Python developer, you can use PySpark. In case you are R engineer, you can use Spark R. In case you have built the entire program, whether it's in Python, Java, or Scala, you can use Spark Submit to submit the program. While the first three commands, let you let you talk to Spark interactively, while Spark Submit lets you submit the batch jobs. Okay, what does it mean by batch jobs? Batch jobs means that you submit the work, it does the work, and then exits. While the interactive shell keeps running, stay connected with the yarn, and then keep on getting keep on executing your program. Spark SQL runs the Spark SQL interactive shell. Okay, so these are the these are the commands that you might be using. These are the commands that you might be using. Okay, so you can simply say Spark shell. Okay, and let me just show you in case. So I'll be taking you through the CloudxLab only, and I've not installed on my local machine. Okay, and let me take this tab outside this window so that I can switch between the tab. Okay, so it's easy for me to sift between the windows than the tab. All right, so let's take a look at the console. How do you go about it? If you have signed up with CloudxLab, in the My Lab, you will get all of the details. So you click on Web Console, okay, and take the login, put it here, take the login, put it here, okay. And here you can simply say Spark shell, okay. All right, you see so much of things scrolling. It's just basically the debug messages, and you can see that it would be trying to connect to HDFS. And if you see these errors, don't worry. What happens is when you launch Spark Shell, it creates a network service so that you can take a look at the UI. Here, it's trying to bind on 4041. It is trying to start Spark UI at this port, but since some of you might be using it already, it's trying now 4042. Now that one was also busy. Then it tries 4043. That one was also busy. Then it tries other ports. And finally, it was able to get 4044 as the port. Now, if you want to take a look at the Spark UI, what you do is you find out the port, find out the host name, and go to the browser and say the port number. Okay. So with this console's host name, you append the port to it, and you will get the UI showing the status of your Spark shell. It says that it is empty, nothing much is going on as of now. Okay, and yeah, the whole thing is kind of empty, not much is being done. All right, also please note that in case of Spark, this one is running older version. Okay, I'll show you the newer version later. Right now it's running an older version. All right, let me see if I could scroll up and show you. You can see it's running 1.5.2 version. Okay, I'll teach you how to run the newer versions. Okay, so this is the, if you look at it closely, I've just run spark-shell. It's just spark dash shell. Okay, now if you look at this closely, it's nothing but a Scala shell. What is a Scala shell? Here you can write your Scala programs. Okay, like 2 plus 3 is the most complicated program, right? It adds it to 5. All right, so this is a Scala shell in which you can give your Scala code and it'll interactively execute. You can define a variable like where x equals 2 plus 3. Now x means 5. Okay, so this is your Scala shell. Along with the Scala shell, what extra is there with this Spark shell? You get SQL context called SC. Okay, so this is the extra variable you get along with one more extra variable called SQL context. Okay, this SQL context is connected with Hive, with which you can interact with Hive, while SC is your gateway to Spark, right? So the way in case of your browser, JavaScript gets an extra object called document and two extra objects actually, document and window, with which you can interact with window and the document. In the similar way, Scala has got additional variable, okay, called SC here. So here Scala is being used as a generic programming language in which there is an object SC and there is another object called SQL context that is basically your gateway to Spark. Okay, so Spark Shell is nothing but Scala plus these two variables. All right, so here you can write your Scala programs. All right, now similarly, if you are coming from Python background, you could use PySpark. PySpark is what? Python interactive shell. What is interactive shell? In which you write a Python program. Here you can write any kind of Python program. Let's say I'm defining my function x, which is taking an argument x and returning x into x. Okay, so I could use it this way. So you can see that it has computed the multiplication. So it's nothing but PySpark is nothing but Spark shell along with two extra variables called SC and SQL context. Okay, SC is the Spark context. SQL context is your context with which you can talk to the structured data sources like Hive context. Okay. All right. So this is your gateway to these are two variables that are added additionally to your Python shell. I'll show you how does normal Python shell looks like or Scala shell looks like. Scala shell looks like this. You can see here you could do all kinds of computation. It's very similar to what we saw in case of Spark shell. Similarly, Python shell looks like this, right? Okay. So Python plus SC, SC plus SQL context is equals to PySpark, right? Okay, and similarly, Scala plus SC plus SQL context is Spark shell. All right, so that's what it is. I'll just try to type something. That's all. Okay, so now next thing which we would like to understand is, so if you want to use Spark with Java, what you have to do is you have to write the code in Java and use spark-submit with your jar. Okay, with your jar file. This will submit the Spark. This will submit your jar to Spark. We'll learn as part of this course, we'll learn a basic example with Java. We'll learn a basic example with Python, but rest of the course will be in Scala. All right. Now, coming back to the point, um, okay. Now, let's try to see few more things. One is this Spark is older. When we ran Spark, the PySpark, it was 1.5.2, right? But why? Because it is by default installed with our Hortonworks installation. Therefore, this is older one. So what we have done is we have installed newer versions for you in this folder /user. So you can see here there is Spark 1.2. This is the older version. Why we have done it? So that people can use in case of Cloud test. In Cloud test, they still ask about 1.2. Now, in one of the tests, not all. Here we have 1.6 version, 2.0.2 version, and 2.2.0 version. So I'll show you this version, okay? So the way you execute is user / then you specify the version number and the folder name. And inside bin, you have, let's say, Spark Shell. Okay, you have all programs here. If you press double tab, you will see the list of all programs in this folder. And here, what you have is Spark Shell. Okay, let's just try Spark Shell. Although you can see that there is PySpark and there's Spark SQL, there's Spark R, and so on. Okay, so we'll talk about all of these components as we go into the class. So here we are launching the Spark Shell. With the Spark Shell, we have bundled the these CSV and other components. Okay. All right. Okay. It's just trying other ports. That's all. Okay. So you can see that this is 2.2.0. Okay. Since I'm on either CloudxLab, there could be minor differences between E and F and G. Okay. Now here, this is a little newer version, but there won't be much difference from 2.0.2. Okay, so the most important part to notice here is now there are two objects. One is called Spark, another is called SC. SC is capped for the backward compatibility, but in the newer version from Spark 2 onwards, your gateway to Spark is Spark. Okay, while SC is equal to Spark dot Spark dot the Spark context. Okay, so basically these are minor changes, but most of your program will as such work between Spark 2 and Spark 1. All right, so this is the way you can launch various versions of Spark. Right here, let's say I want to launch, I've just pressed double tab and let's say this one, and I'm saying bin / Spark Shell, so I can launch that particular version. Okay, so this one is 2.0.1. Okay, we'll be installing newer versions as and when the newer versions are coming on all the nodes. Okay, now coming back to the point, there are minor differences. The biggest difference is that in Spark 2, the main gateway is Spark. Earlier, the main gateway was SC. Okay. All right. So this is the interactive shell for this version. Now let's move ahead and test one simple program. Okay. Let's go ahead and test a simple program. So this is how you do. Now, This I have talked about already. In case you want to say find out, in case let's say you want to find out what are the various the documentation of SC object, you could simply say help SC and you will get the documentation. All right. Okay. All right. So a question from Samar as well as Dinesh. What is the difference between SC and Spark? In Spark 1, there were two objects. One was SQL context and other was SC. Now, both of these objects have been brought under a single object called Spark. Spark is essentially a object of a class called Spark session. Okay. And that's what it is. All right. So that's the so you can say that Spark has both SC and SQL context. Okay. This was in version 2 onwards, and this is these were in version 1. Okay. All right, that's what it is. Though SC is capped as here, the SC in version 2, SC in version 2 is capped for backward compatibility reasons. Okay. We will go into more details in case how to create these variables by yourself if you are not using interactive shell. Instead, you are submitting a program. In those case, let's say you're creating your own Spark SQL program, Spark program that you want to submit as a job. In that case, SC and Spark objects you will have to create by yourself, because there here when we ran interactive shells created those objects for you. Okay, but in case you want to submit your job, your program need to create those objects. So we'll talk about that during the course. Okay, now here is one simple example of Spark Summit. Let's take a look at this this particular example. Okay, so here is the example. So what we are doing is we are submitting an example program. This is the example program, which is basically a jar file. What is a jar file? Jar file is a bundle of Java bytecode. So when you create Java programs, you write your code in .java. Those .javas get compiled into .class, that is Java bytecode, that's kind of binary data. And when you bundle a lot of multiple programs of yours, which are in .class, you generally bundle them in the form of jar. Jar is .jar files are generally like .zip files. Okay, just that they contain the Java programs. Okay, now here, this one contains Spark examples. And here we are saying that this is my bundle of code. Okay, asterisk means all the files is starting with this name and with this prefix. And we are saying that this is my bundle of code. Out of this, my entry point is this class. Okay, and what it does is it computes the value of pi. It computes the value of pi using multiple computers. All right. So this is where I'm going to use, not this one, I'm going to use this. All right. So it is starting the program like batch process instead of interactive this time. And here it's trying to compute the value of pi. You can see it's computing the value of pi, and it has computed to 3.139552. All right. So this is our simple example. All right. Is it clear to everyone? Now, question is, why do we need the how we are how we are computing the value of pi using Spark, and how is it helping? Okay. A question from anonymous attendee is, it'll be great. I'll be grateful to you if you please put a name. That becomes easier for me. It puts more human face to it. So yeah, it's okay. I mean, you can, if you don't like your name to be displayed, put some name. Okay. So question, it's a very good question. What's the number 10 in the example after the jar name? Okay. What's number 10? Let me describe it by the way of this example. Here, here, what we are trying to do is we are trying to compute pi. And how do you compute pi? Pi is basically a part of this formula that, what happened to my Q&A window? Okay. All right. Let me exit from this and, uh, okay. So what is pi? When we draw a circle, right? The area of this circle is pi into radius. Radius is the distance from the center to the end, right? So what we have done in the example is we know the radius of the circle. We know we want to compute the pi. And how do we compute the area? We can count the total dots in this circle. In this example, what we have done is we have probabilistically computed the area of the circle. And how do you compute probabilistically? What you do is you draw a square. You draw a square surrounding, you draw a square surrounding your circle. Okay. And then what you do is you go from, sorry, okay. Okay, let me draw a proper circle for you. Okay, so what we are trying to do is we are trying to compute area because we know the radius. Okay, so we've taken some radius and we have drawn two things. We have basically drawn a square. Okay, and what we do is we go from, okay, what we do is we draw these lines. Okay, I'm sorry, but yeah, be with me for some time, even if you're not interested in maths. But here, there's an important thing that's happening. Okay, so what we have done in this case is, what they have done in this case is, they have gone from all values of x from this point. This is, let's say, 0, and your radius is 1. So this is -1, this is 1. So they've gone to from this to this and put dots everywhere. You've put dots everywhere. Okay, you have put dots everywhere, and while putting the dots, it has counted, it has figured out whether this dot is inside the circle. And how does it do? It finds the difference between the origin and this point. If this distance is lesser than the radius, meaning 1, that means the dot is inside the circle. And if this is here, the dot is outside the circle. So counted the number of dots inside and outside the circle. And since we know the area of the square, we computed the proportional area by the number of dots. We computed the area of the circle. Did it make sense to you? Now, what is tan here? Tan is basically in how many parts do we want to divide this? In how many parts do we want to divide this? Okay, that's tan. All right. So what it did was it divided into 10 parts, and then it divided it put 10 points here, 10 points up, 10 points down, everywhere. So that's how it computed the total number of dots inside and outside, and in the total number of computed total number of dots inside and outside, and based on the proportions it computed the area, because we know the area of a square, and based on the proportion number of dots it figured out the area of the circle. That's what is happening. So the more number of dots, more number of this, the bigger this number is, there will be more dots, and hence the value of pi will be more accurate. If I put here, if I put here, say 15, it's going to be taking a longer time, but the value will be far more accurate. Okay, here this time it has given me the the value as 3.14, you see. And if you put more bigger value, say let's say 50, it's going to take far more time this time, and the value is going to be more accurate because there are more number of dots we are putting. Okay, so Spark Submit is essentially submitting this program, this bundle to Spark, and it's launching this class. And this class is having that logic in which it first divides these data points and creates an RDD out of these points, and gives and executes the logic in the form of map reduces to compute how many points are in the circle and how many points are outside the circle. You want to take a look at the example code. You may want to take a look at this example code. All right, those who are more inclined to understand the logic. Here, this was the easiest way to execute something. Okay, that's why we have taken this example. All right, so using a heuristic way, we were able to compute the value of pi. So we first computed the number of dots inside the circle and figured out the area of circle based on the proportional number of dot points, and then used that area of circle to compute the value of pi, because we know the radius, we know the formula. Okay, so more the number of slices, or more the number of dots which we put on the circle and inside the square, more number of points mean more accuracy. Okay, the heuristics gets better. Did I answer that question, Titu? Great. Now, if you want to, let's say you have downloaded Spark for yourself, and you would like to launch Spark on Hadoop, meaning when you access the file, it should read the file from HDFS. Please set these variables. Uh, this is the newer variable. This is just for backward compatibility. In the Hadoop one, this was the variable used. Therefore, we use the two variables. Now, again, the point I'm trying to make here is, as we discussed earlier, Spark Spark runs on top of Hadoop, correct? Everybody agrees with that. Spark runs on top of Hadoop also. All right. So to know about Hadoop, to know about which machine is what, Spark needs to know where is Hadoop installed. And how does it know? You just point these two variables to the configuration files of Hadoop, because those configuration files contain everything about Hadoop. Okay, so you just have to set these two variables to the folder in which your Hadoop's config is installed, and that should be done. Okay, and then Spark will basically, when we run PySpark, Spark Summit, or any other thing, they will discover information about your Hadoop or Yarn cluster using these variables. All right. A question from T2 is that can we see the Spark UI for Pi execution? Actually, since Spark Submit ends the process as soon as the work is done, Spark UI will appear for maybe few seconds as long as the process is running. Okay, so it'll be difficult to see the Spark UI for the Pi execution. Good question. All right. So similarly, you could also use these commands. We have already tested that. All right. So this was a quick overview of Spark. Let me answer a few questions and then see if we can do a word count. So Sanjay, did I answer your question earlier? The logic. I think what we do is we will maybe take the logic in one of the sessions later on, because this code here in Spark Pi is actually a little advanced. So I would love to answer this. I'd love to walk through this maybe at later point of time. Okay. Honestly, it's not much needed. The idea was that this is how we generally launch our Spark programs. All right. Great. Good question. I would personally love to answer this question too. Okay. Yeah. Great. Great. And yeah. So if you want, I'll just go over the basics of oddity and then we will take okay. All right, let me just take a look at not this one. Yeah, this one. Okay. All right. So okay, so I'd like to just go over basics of oddity and maybe do a little hands-on. Probably that'll be good with everyone. Or maybe we can just do the hands-on and come back to the theory. Okay. All right. So what we'll do is we'll do a hands-on. I know that you will all feel out of place because it looks we are just jumping into code without talking about Scala. Okay. But it is very important for all to get hands dirty so that we set our expectations right. Okay. So um, not too much of theory. I don't want to answer the question right away. Let's just do a bit of let's just do a hands-on and then I'll come back to your questions. Your questions are very valuable, but I know that hands-on is more is very important for all of you, and therefore let's do a little bit of hands-on. Even if you don't get everything right now, okay, just be with me. Okay, just be with me and I'll try my best to explain things. And yeah, and although this example will come again after 3 sessions, because we'll talk about all kinds of operations in details, but but I would like to just jump into this right now. Okay, because whenever you're learning a programming language or anything in the technology, there is always this problem whether to do a little hands-on or do the theory first. Okay, when I do the hands-on or do the theory first, and that's where the confusion arises, because if we talk about too much of theory, all of you will go to sleep and it doesn't make sense, right? And because without doing hands-on and without asking question, you would not actually remember anything. Okay, and if we just jump into the hands-on, most of you will feel awkward. So I'm quite inspired by a book by Cunningham and Ritchie. What they do is they start their first their first example with, they just start their first chapter with an example and then they gradually build upon it. Okay, so I will also try to do the same thing. I'll just take a very simple case and we will do more and more of this. Okay, so let's start with Okay, so the first way is the easiest way to create an RDD is either, okay, let me also do something like this. Okay, I will see if I can. All right, so I'm going to launch Spark Shell. Okay, and let me just take a very simple example, very simple example. Okay, and here, okay, I'm just little thinking whether I should I give you this one and you would like to go through this one. I think this will be good enough. Okay, all right, I'm going to put it in the chat box. Okay, so let's just walk through it. Okay, in this first line we are talking about Spark context. Okay, we are asking Spark to load this text file. Okay, what is this text file? It's a text file in HDFS. Let me show you where is it located. If I go into Hue, right? If I go into Hue, you'll be able to see in the file browser, okay, there is a file. Not here. Go to the top level. This is HDFS. In HDFS, it is exactly like normal Unix file system. The whole story started slash. So we have copied the data that is used in the session in the slash data. In the slash data, in the here in the MR, the word count example, there is an input folder, and there is big.txt. Although the name is big.txt, but it is only 6.2 megabyte. Okay. And what it has is it has the some of the text from the book of Sherlock Holmes. Okay. And there is some more data from here and there. Okay. So what you can do is, what we have to do is we have to take the text of this file and find the unique words and their frequencies, meaning how many times each unique word has occurred in this. Out of this file. So we have to find the unique word and their frequencies of this file. All right. So how do we do? So we will first load this text file. We'll break each line into one word per record. And then we will basically reduce by key. Okay. So what we're going to do, I'm just going to show you with 2 lines. All right. I'm going to show you with 2 lines here. Okay, like this. Okay, so first of all, we are going to replace space with new line, as in we are going to split the data, not like this, okay? And then we're going to kind of sort it, and then we're going to basically combine the things. Okay, we'll go into more details as we proceed in the session. So first of all, let's create the RDD using sc.text file. Okay, this will generate an RDD. All right, so let's see. I know it won't make too much sense right now, but be with me and I'm sure you will get the overall picture. Okay, you will get the overall picture. So right now, we just created an RDD here. Now this RDD is not your normal object. It's a, it's a, it's a RDD from Spark. Okay, it does not contain data. It just contains the instruction that your file is at that location. Okay, your file is at that location. That's what it contains. So RDD is nothing but a pointer to the data. All right, let's remember it this way. So we just created an RDD. Now to understand what's inside an RDD, you can use a method called take. So here we are just saying take 5. Okay, so take 5 shows you that it's an array of 5 elements. Okay, this is first element. this is second element, and this is third element, and this is fourth one, which is empty line, and this is fifth one, right? So basically, each record in case of an RDD is a line from the text file. Is everybody clear about this? Each record of the RDD, we have said, give me 5 records. We've told RDD to give us 5 records, and it gave us 5 lines from the text file. So if we are loading our data, from a text file, that means we are basically we basically um, we're basically creating an RDD 1 record per line. So how many records will be there in the file? Quickly, how many records will be there in the RDD? Will it be equal to the number of lines in the file? Okay, so let me show you if okay, I think there's a method called count. So you can see that it has these many lines. Okay, these many lines, and if we use a Hadoop fs cat command, you will know that it has those many lines. Okay, and how can I just do a computation here? All right, so if you take a look at this file in more detail and you download it and count the total number of lines, you will know that it has those many lines. It has 128,000 lines. Okay, so 1 per record. Is everybody okay with it so far? No? So we created an RDD out of this data, and we also checked what's inside this. Okay, what's inside this? Now we can run various kinds of functions on top of this RDD. Okay, let's say there is a function called uppercase. Okay, let me just show you the function name. What it does is it converts it into uppercase. Okay, uppercase. All right, so what we're going to do is we're going to call this function against every record of this RDD. What was the name of the RDD? The name of the RDD was lines. Okay, now we are going to say lines.map. Okay, and say underscore means the first variable, whatever we have here, and to uppercase. All right, I know that you are not going to get everything right away, but trust me, it's going to be quite helpful. Okay, let's assign this to a newer variable called let's say up RDD equals this. Okay, so what's happening here is whatever lines we have created, this function is going to get executed against every record. Okay, against every record, and what this function is going to do with that, with every record, it's going to convert that to uppercase, and this up RDD would contain those records. So let's show you. Take 5. You can see that our lines, in the newer RDD, the data is uppercase. All right, so this was a very quick hands-on with this. Now let me just walk you through the word count. Okay, so you want me to give you this? If you want to try it out. Okay, and all right, but before running this command, please create the RDD using this one. Okay, now this was a very simple one. Let's try to do a little more complex. So here in the second line, we are converting one record into many records by splitting. Okay, by splitting. So let's take a look at what we have just created by using take method. Okay, so you see here 5 record means 5 words. Okay, 5 words. That means now our newer RDD is made up of records. Earlier RDD was made up of lines, correct? Now let's convert each record into tuple. Okay, now take a look at what's there inside it. So we could again use a take method. All right. Okay, so we'll go into more details as we proceed. Then we define a method called sum. This basically, okay, actually that's not required. Okay, now we created this kind of RDD that can, every record in this RDD is basically a pair. The first one contains the name, each word, and the second one is a fixed number, 1. All right, then we use reduce by key. Reduce by key basically works like group by in SQL, just that aggregation function is provided as argument. And here this aggregate function means sum, meaning group all these records based on group all these records based on the key and sum up the values using the addition. Okay. All right. It's going to take a while to finish it. Now, once it's done, you will see that output, you see, output is again an RDD which contains the records. Okay, let me show you what does output contains. Okay, output contains the counts of everything, right? Here the bone has occurred 350 times. All right, so you can see that this output RDD contains the result. Now we can save this output RDD using a function called save as text file, and here we are saying this. So let me just change this name. Okay. All right. So RDD dot save as text file, and this is the folder in which it's going to save the result in HDFS. Okay. Now let's take a look in HDFS if this folder has been created. Okay, I go to my home directory. Since I gave a relative path because my path of the directory did not start with slash, therefore my this demo example is created in my home directory. My home directory is this. If you sort the data by, everybody gets a home directory in HDFS in CloudxLab, and here is the folder. You can see that just like word count in Hadoop MapReduce, you get 2 files. Here also you have got 2 files. Okay, these contain the results. Okay, these contain the word count. All right, so that was our quick rundown of a program. I'm sure that there are many doubts in this, but as we go through the course, we will learn each and every part of it. Okay, so this was just to break the ice, just to subconsciously, as you execute this program, subconsciously you will realize what does Spark programming looks like. There's a lot of learning that happens which you don't realize while you do the hands-on. Okay, so this is the programming way of manipulating data. There are data frame kind of manipulation as well that we will learn as part of this course. Okay. All right, there are few questions I would love to answer at this point. Okay, so are you able to, did anybody else try with me in the class? Great, great. Okay, Fakhruddin tried it, Rakesh tried it, who else? Okay, T2 also did. Wonderful. Who else? Okay, feel free to answer. Is somebody trying it right away? All right, great. So to exit the Spark shell, you can press Control D, Control and D, and you will exit the Spark shell. Okay. All right. So Dinesh, did I answer your question regarding Spark SQL context, Spark context, and Spark session? Spark session is Spark 2 idea, which actually contains both SQL context and Spark context. Okay. A question from Konar. We saw the output in two files. Can you explain this? Yes. The resulting RDD had two partition. And when we save, if you the this particular one, this output is an RDD, it has two partitions. And when we save the result, it basically saves one partition in a separate file. Okay. Every RDD has got partitions, and every partition contains multiple records, and every partition is generally located on multiple machines. Okay, so RDD is the basic unit of computation in the Spark, and every RDD is made up of records. Every RDD is made up of partitions, and every partition contains records. So partition is the unit of parallelization, meaning every partition will be processed in parallel using multiple machines in Spark. Okay, was I able to answer, Kunar? All right. Kunal's question is for three Spark abstractions, data set versus data frame versus RDD. Can you please tell the use case of each? So we will actually go into more details into one of the sessions. For now, you can understand that data set or data frame is basically for for structured data, while RDD is for raw data. And the general strategy is raw data is in unstructured data. RDD is unstructured data, while data frame or data set is structured data. We'll go into more details about the difference between data set and data frame. Also, the general strategy is that you take the raw data or unstructured data in the form of RDD and convert that to data frame using all kinds of programs and operations. Okay, and and hence and hence you would be able to process all kinds of data using these two constructs. Okay, so if your data is unstructured, load it as RDD, and then using various mechanisms using ETL, you'll be able to transport, convert that into data frame, right? Using map, flat map, and all kinds of transformations provided by Spark, you'll be able to convert unstructured data into structured and then process it using SQL. All right, good. So a question from Dinesh is partition count configurable? Having more partition will consume more memory, right? No. More partition means more parallelization. More parallelization would be better. Okay. So general strategy is that the partitions are generally decided, the initial partition of RDD is generally decided by Spark for you. Okay. And then the rest. All right. And so more partition will consume more memory, um, a little bit more memory, not much. Okay. But having more partition wouldn't make more sense if the partitions are more than number of containers possible in a Hadoop cluster. Okay. Because at a time, you can only execute partitions which are equal to the number of containers which can be executed. Okay, we'll go into more details about how to repartition and how to change the number of partitions and how to partition our data such that the data can be concatenated. Like for example, here the two files, the data is overlapping. Therefore, if you concatenate the two files, what would happen is the outcome will not be a sorted result. Okay, that's where partitioning, you can repartition the data. Okay. A question from Vinod: Are Spark Scala commands case sensitive? Yes, they are. Okay. Most basically, it's not about Scala Spark. It's about Scala. Scala is case sensitive, and as a matter of fact, probably except for VB, all programming languages are case sensitive. Okay. I think VB was case insensitive. All right. So yes. So if you are even if you're here, let me show you. Even if you are in Scala, I just launched a Scala command. Let it start. Okay. So here, if you say where x equals 2 plus 3, right? So x is 7, but capital X is not found. Okay. Therefore, Scala is case sensitive, and therefore Spark Shell is case sensitive. Good question. A question from Anand. I kind of missed this question. Is Flume a pull or push? What I mean is, does it push file from web server or pull from HDFS? Okay, very interesting question. Who can answer this? I would love to see if somebody can answer this. It's a hard question to answer. Okay. Okay. Actually, the way you always look at Flume is in this way. Okay. Flume is like this. It has a portion called source. It has a portion called, this is called, this is called source. This is called sink. And this is called channel. Okay. Now, the source can be configured, and sometimes it could be a command or it could be something else. So it could either be, this one could either be like a service listening on a certain port, right? Service on a certain port, or it could be a command. All right. So if it is a service, then other systems can push the data to it. If it's a command, then it can read by itself. So nobody has to push anything here. While sync in a similar way. So what it does is, what Flume does is reads data from source, puts it channel, and from channel sync reads. Uh, from channel, the data is pushed into sync. Okay, so you can say that this part pushes data to target. Okay, yes, thank you, Summer. Good. All right, yes. Question is, how is the concept of name node and secondary name node as well as cluster work in the context of Spark? Wow, that's an interesting question, and I would, okay, so if you are part of the other class, I would love to explain this, and there is a full half hour or 45 minutes dedicated to this. And okay, so actually the question is far more deeper than what others are thinking. Question is, on one hand, we have on one hand we have the HDFS, right? On one hand, we have HDFS, okay? And on the top of it, you can think of it like this. Let me draw it. On the other end, we have yarn, okay? I'm just trying to, or we can actually like this, right? We have yarn, okay? So, right? So we have yarn. Yarn has many things like inside it. You have, let's say, uh, first node, second node, and third node. So let's say three nodes. On each of three nodes, we have HDFS service running and yarn service running. Along with that, we have yarn's master and HDFS's master. How does Spark talks to each of them? Okay. So basically, if you think of Spark here, okay, what it does is when you say sc.text file here, sc.text file here, what it do is it'll ask HDFS about the file, okay? HDFS, when I say, it'll be name node, then data node, and so on. And then it'll find out what are the data blocks and other things, okay? Once it gets the data block, what it does is it talks to Yarn, as in Yarn means the resource manager, and tells it that can you please execute my program nearer to this data, and this is my program. All right, and then the actual work will be run inside all of these machines. Okay, that's how it happens. So your data is in HDFS, Yarn is executing it nearer to the data. Okay, if we can I draw a file some way? So let's say this is your data, this is your data. Okay, I'm just drawing it really ugly. Okay. Okay, so let's say there was a data you broke down into data blocks, put it on multiple machines. On all of these machines, there is a node manager running from Yarn. And so Spark first finds out where is this file located on which all machines. And then it goes, actually, it just tells Yarn that, hey, my file is this. Can you execute my program nearer to this data? That's what Spark tells Yarn. Yarn can execute any job, okay? Any job. And when you are executing Yarn, you can kind of provide, when you're asking Yarn for resources, you can kind of provide the specification for resources. All right? Wonderful set of questions. Okay. So this was a quick overview of Spark. If you have more questions or if you want me to cover something today, I would love to cover that part. Okay, from next Saturday onwards, we are going to first start with Scala, and then we will talk about Spark. Okay, next Saturday, we are going to work with Scala, and we'll just get acquainted with these Scala and then come back and start from basics of oddity and understand things in detail and learn how to process unstructured data first, and then we will go over to structured data. Okay, because you can process structured data using unstructured data tools, but not vice versa. Therefore it's better to process the data using RDD first, so that if there is unstructured data, you can first process it and convert it later into structured data formats such as data frame or data set. All right, any more questions for me? I would love to answer your question. Can I did I miss your question? All right. Do you want me to cover something specific? Yes, you've raised a hand. All right. So we have a couple of seats in the current course of Spark with Scala. So you can go over to CloudxLab and sign up for the class. All right. And a question from Kunar is how to use REST API with Spark. A good question. So Spark does not provide you a REST API interface. I'm not sure if there is a third-party service which provides you the REST API interface. Okay, and mm, and therefore, okay, so there is no REST interface for the Spark, but you can always create one. A question from Vinod. Could you please tell a bit again on GraphX? Sure. So GraphX is basically for graph processing. What is graph? Graph is basically, just allow me to pull my, okay, okay. So GraphX is basically for processing graphs. Okay. So what is a graph? Graph is essentially a data structure such as this one, where there are these entities 2, 3, 5, and 7 having relationships. Here the relationship is directional, as in there's a professor who is a colleague of another professor, and there is a professor who is an advisor to a student, and a student is a collaborator with a postdoctoral candidate, and so on. Okay, and right. So this is a graph, and a graph computation could involve finding common friends, finding the page rank, and many more. Say, for example, we want to find common friends or finding page rank, like a Google page rank, in which you find out who is more important from a graph of friends or graph of pages. Okay, so GraphX is basically for graph computation on Spark. It provides you a way to represent the graphs in the form of RDD internally, and then it provides these algorithms on top of that data structure, on the graph data structure. So GraphX one is able to convert a graph data structure into an RDD, and then it also provides you algorithms to do various kinds of complex computations. I hope that answers your question. A question from Tito is that will you be covering more about partition and clusters in future classes? Yes, we'll talk about more of partitioning, clusters, and so on in the future classes. Okay, so this was a first free session of the course. So if those of you have already enrolled, that's good enough. And those who have not enrolled, you can enroll going to cloudxlab.com. Okay, you can go to cloudxlab.com and you'll be able to see that. Okay, you can enroll here. All right, so you will also get an email from our site. Okay, so before next Saturday you can do that. There are a couple of seats available. I'm sure they'll get filled up very quickly. A question from Prithvi: what's the difference between Spark parallelism and distributed computing using oddity? Spark parallelism is achieved using the RDD's distributed computing. RDDs are broken down into partitions. Every partition is parallelly computed. Now, a very interesting question here is, okay, let's say you have 4 cores, okay, on a single machine. You're running Spark in local mode, Spark in local mode, okay? In that case, there'll be, when you execute RDD, it'll have 4 partitions and one partition per core. Okay, this is what will happen. If you are running Spark in cluster mode, okay, that is like on Yarn, okay. If you're running Spark on the Yarn, what will happen is, and what will happen is number of partitions would be function of data, okay, would be function of data. Okay, all right. So thank you, everyone. I thoroughly enjoyed your questions. Feel free to reach out to us at reach us at CloudxLab. Okay. feel free to reach out to us at cloudxlab.com. So that's pretty much. You can enroll for the course by going to the cloudxlab.com, and that should be good enough. All right. I look forward to see you all in my next session, which is on next Saturday. Okay. We will start from the basics in that session. We'll start with Scala, then we'll go with basics of oddity, and then we'll continue solving large scale problems using Spark. Okay. Thank you, everyone. I look forward to see you in my next session. Yes, of all of you in this session will get the recording of the session. Also, we will make this recording available on our blog post. Okay. Great, wonderful set of questions. I hope that this was useful for you. Thank you, Rudra, that you find the session useful. All right. Thank you, everyone. I look forward to see you in the session. Okay. This session would be great starting point for all of you if you are planning to start with Spark. This is more than sufficient to get you started, and rest you can take it forward. Okay. Thank you, Ganiti. I'm happy that you liked the session. All right. Great. All of you, I look forward to see you in the next session, and have a great week. Bye-bye.